If you can, please download or print out the PDF file on the description below so you can work with me. A tree. A tree is a graph that has only one edge between two vertices and does not have any loop or cycle. So this is a tree because it only has one edge connected to vertices together. Another one. This is also a tree because we have three edges that connect the four vertices together and there is no cycle or loop. Now this one is not a tree because this network has a cycle because these three vertices and then the three edges connect together make a cycle. So therefore this is not a tree. Spanning trees. A spanning tree is a tree that connects all the vertices together on a graph. Of course, this one is not a tree because it has so many cycles on it. So in order to make this a spanning tree, we need to remove some of the edges. So let's move some of the edges. So remove that. And I still have cycle. So I'm going to remove until it's no more cycle. Okay. So we remove this and we need to remove one more. There you go. This is a spanning tree because every vertices are connected together and only one edge between them. Another example of spanning tree. I can remove different edges now. So we have different spanning tree. So there you go. This is another spanning tree. All the vertices connect together and between them only one edge and there is no more cycle. Let's make a different spanning tree from this network. So just remove different edges now. Again. There you go. This is another spanning tree. Please stop the video and try this one yourself. Find the spanning trees for the network below. Your answer might be different from mine, but doesn't mean that you're wrong, okay? So just make sure you connect all the vertices together with only one edge between them and there's no cycle. Now we just remove all the cycle. So we can remove all the edges that make a cycle. So I'm remove. There you go. This is a spanning tree. One of them. And another one is I can remove this edge and then remove one more. There you go. This is another spanning tree. Now I'm going to remove different edges now. So remove this, remove this, remove, and remove this, and then to remove one more. There you go. This is another spanning tree. Let's move on to minimum spanning tree. A minimum spanning tree is a tree with the least total weighting on the edges. For example, identify a minimum spanning tree of the network below. So looking at this network is not even a tree because it has so many cycles on it. So we need to remove them. But this time, remove the heaviest weighting on the edge if possible. Not always the case, but let's see. Because with this network, I can remove this and I remove this. See, it become a spanning tree. But this is not the minimum. So in order to do this, so I'm going to try to remove 10 or 7, 10, 7 or 6 depend. Okay. So let's have a look. So first of all, I'm looking at 10 now. So if I remove 10, these 4 vertices still connect together. So which is good. So that means I can remove the 10 out. Then I'm focused on 7. So if I remove 7, see what happened, okay? If I remove this out, so these 4 vertices still connect together. So these are the 2 heaviest weighting. So we remove that 2 out, which is good, and it works. So therefore, I remove this out. So this is removing these edges by inspections. Now, your turn to do it yourself. So please pause the video and try this one yourself. By looking at this graph here, we have 4 vertices and then 1, 2, 3, 4, 5 edges. So obviously, it's not a spanning tree. So we need to remove some of the edges so it becomes a spanning tree. And also, it is minimum spanning tree. So to do this, of course, the idea is to try to remove the edges that have the heaviest weighting. So let's have a look. So this is just by inspection, okay? So to do this, let's try to remove 13, because 13 the most heaviest weighting. And then of course, I can't remove 12. Because if I remove 12, what happened? A doesn't connect with D or doesn't connect with B. Because I removed 13, so I have to leave that there. Then the next one is we focus on 10. Because 10 is the heaviest after 13 and 12. So we try to remove 10. So if I remove 10, so what happened? So you have 8, you have 7, and then 12. These edges connect the 4 vertices together. So I can remove the 10 and the 13 now. So if I remove them out, that's what I get. Now this is a simple network. That's why you can do by inspection. In fact, by inspection is very difficult. There are rules to work this out. So next video, I will teach you the rules to work out the minimum spanning tree. Thank you so much for watching.